Good afternoon. So today we'll discuss the unit 3, that is optoelectronic devices. The content of that optoelectronic devices is electron emission. What are the different types of emissions? Then what are the different applications we are seeing? Then we are having so many components or so many devices, that is photodiode, optoisolator, photovoltaic cell, LED, LDR, LCD, optocoupler. For these devices, we are seeing the symbols, what are the symbols to be used and how it is going to be working and where it is being used, that is the application. So, and course outcome 3, that is analyze optoelectronic devices. So we are going to cover these topics. What is meant by optoelectronic devices? So here the two terms are being joined, that is opto and electronics. So opto means it is nothing but a light. The device which are being related to the light, or the device which are going to utilize the light as a signal to do some applications. So therefore, optoelectronics is a technology that combines optics and electronics. This field includes many devices based on the action of the PN junction. That here all devices are being of semiconductor material, that is PN junction we are using. Using the PN junction, so here we are going to have different devices, that is light emitting diodes. So it may be or a photodiodes or optocouplers, and LASCR, that is light amplification by stimulated emission of radiation diodes, are the examples of photoelectronic devices. The relation between light and electricity was first observed by Hertz. He is a scientist who has been observed in 1887 and has termed the photoelectric effect. He has been pronounced as a photoelectric effect. This effect includes the generation of electron-hole pair. So as the temperature is being raised in the semiconductor, as you have been seen in the second chapter, that is a diode, PN diode. So where the semiconductor material is very sensitive for the temperature, as the temperature increases, the electron-hole pair are going to be liberated. So this effect includes generation of electronic hole pairs in semiconductors. It initially referred to as emission of electrons from a metallic surface. The device that resulted from this emission were, so by using this technology, they have been introduced a vacuum and gas phototubes, and were commonly called as a photoelectric devices. So previously, before introduction of the semiconductor material, the peoples are going to use a vacuum tubes. So what is that vacuum tube? So by this, they are going to emit the electrons from the surface of the metallic surface by giving some other, it may be connected with the electrical field, or it may be given a heating treatment, or there are so many ways. So by somehow it is being emitted the electrons, so there they are going to call them as a photoelectric devices. But after the introduction of the semiconductor material, the modern solid state devices, which includes emitter sensors and couplers, usually known as optical electronic devices, or shortcut it is an optoelectronic. Sometimes it is also called as a electro-optics. There are two other categories in the area of optoelectronic sensors, that is optoelectronic devices such as light emitters. So what these devices is going to convert? It is going to convert the electrical energy into light energy. For example, the junction LASCRs or LED. So once the LED is being connected forward biased, so this is going to emit the light. So therefore, the electrical energy is being converted to the light energy. Whereas photo detector, another device which has been called as a photo detectors, do the just opposite to the light emitters. What the light emitter is going to do, electrical energy is being converted to light energy, and these photo detectors will convert the light energy into electrical energy. For an example, the Faraday has been invented, the bulb. Sorry, Thomas Alva Edison has been invented the bulb. And the bulb, what that device, it is going to convert the electrical energy into heat energy. And this heat energy, which reacts with the inert gas and it emits the light. So that heat energy is being converted to light energy. Similar way here also, some devices are there, that devices will convert the electrical energy into directly to the light energy in the optoelectronic devices. And there are another devices which are being called the photo detectors, do the just opposite of light emitters. They convert light energy into an electrical energy. So you can observe the figure here, that is, we have been shown, this is the metallic surface where due to the normal temperature, the electron hole pair are being created in any material. So, but they are moving from one atom to another atom, or they are only moving inside the or at the surface of the metal piece, but they won't come outside, because there one surface barrier is there which is going to hold it not to jump from the surface. So therefore, if I am going to give some energy to these free electrons, or the energy which has been more than the surface barrier energy, then this electron will be just come outside of the surface of the metal piece, and now it is free. That technique we are going to call it as the electron emission. So consider a piece of conducting material as shown below. The free electrons in a piece of metal will move from one atom to another within the metal surface. Those electrons which are being liberated due to the rise in a temperature or any electrical field, somehow these free electrons are being moving here and there and on a surface. However, these electrons cannot leave the metal surface to provide electronic emission. Thus, at the surface of the metal, free electrons encounters force that prevent it to leave the metal. This metallic surface occurs a barrier. So it is an opposition force which has been called as a surface barrier. Due to this surface barrier, the electron which are being already set free, they are not emitting outside the metallic piece. In order to emit the free electrons from the metal surface, its kinetic energy must be increased. So just remember the atomic structure of a semiconductor material, that is silicon. So where the number of electrons are being rotating in a different orbits. So the electrons which are rotating in the innermost orbit are having some energy, but the other electrons which are being rotating in the outermost orbit will have a higher and higher energy. So therefore, the inner orbit electrons, if I am going to provide some energy for that kinetic energy, they may jump from one orbit to the another orbit. The similar way here, in order to emit the free electrons from the metal surface, its kinetic energy must be increased by supplying an external energy. Any type of energy you can apply, and this is known as an electron emission. So electron emission is nothing but the liberation of electron from the surface of the substance is known as electron emission. So here in the, so photons are the energies which are being directed on the metal surface. So these photons will, energy is being absorbed by these electrons and then they are being liberated outside. Similarly here also the photon is being following this. This is free electrons, and when these electrons are being absorbs the photon energy and then it emits and they are free. So what are the different types of emission? Now the liberation of an electron from a metallic surface is being called as a electronic emission. How these emissions can be done? What are the different methodology we are going to use? So that is nothing but a type of electron emission. In order to cause the electron emission from the surface of the metal is possible only if sufficient additional energy is supplied from some external sources. So by naturally it is not possible to come outside, but we have to provide additional or a sufficient additional energy has to be supplied, then only these electrons will become outside of the surface of the metal. Based on this type of additional energy, what type of energy we are going to use for causing electron emission, they are being classified as, first one is thermionic emission. So here thermal. So thermionic means thermal ion. So this is being, thermal means heat. In this method, the metal is heated. The whatever the metal which is having a free electrons are being heated, and with sufficient temperature, the free electrons will get sufficient kinetic energy, causing electrons to enable from them to escape from the metal surface. This is known as a thermionic emission, and this method is used in vacuum tubes. Whatever the vacuum tubes before the introduction of the semiconductor material we are using, so that vacuum tubes will work under the principle of thermionic emission. There, for example, nowadays you can see the CRT, cathode ray oscilloscope. So in the cathode ray oscilloscope, there we are having a one cathode, and that cathode is being heated to a particular degree centigrade such that it starts to emit the electron, and that electron we are going to make to fall on a particular screen, and that screen is being made up of phosphorus material, that when the electrons come and hit the screen, this phosphorus material will absorb the energy and it radiates. So like this, so once the sufficient temperature is being provided for any metal which is being called as a cathode, such that it starts to emit the electrons. Such type of emission is being called as a thermionic emission. And the second type is field emission. In this method, electrons can also be pulled out by the application of a strong electrostatic field. So by applying a larger voltage across these two, such that we can emit the electrons from the surface of the metal. Such emissions are being called as a field emissions. Due to the temperature, the emission takes place, then that is being called as a thermionic emission. Due to the apply of field, if the emission takes, then that is being called as a field emission. Then third one is secondary emission. In this method, a very high velocity electron beam. So here we have been already liberated one electron. That electron we are going to give extra energy and we are making to hit the surface of the metal, such that ejection of the electrons, another electrons when it is going to hit, so that electrons is being, more electrons are being liberated, and that more electrons, again this process of is known as a secondary emission. So yeah, actually first time the electron which is being liberated is made to fall on the another electron, hitting the other atom, such that the more and more number of electrons can be liberated. So that is being called as a secondary emission. Then next one is photoelectric emission. In this method, the surface of certain metals are illuminated by a beam of light. So some materials are, when they are being exposed to the sunlight, they start emitting the electrons. So that type of materials are being called, or the emission is being called as a photoelectric emission. In this method, the surface of the certain metals are illuminated by a beam of light. Electrons are ejected out of these metals by the photons incident on their surface. When the light energy, that the sun energy, is having a lot of photons, and these photons, when they fall on the particular surface of a particular material, then the electrons ejections takes place. Such an electron emission is known as photoelectric emission. These techniques are used in photoelectric cell, that is photovoltaic cell. We are going to use this technology, that is, we are making to fall the light rays on to that material such that the electron emission starts. The emission of electrons from the metal plate when exposed to radiation of suitable frequency, that is wavelength, is called as a photoelectric emission. So here light radiations of having a particular frequency wavelength are being subjected to the material such that the emission of electrons takes place. The process is being called as photoelectric emission. So how these electrons are being emitted and how they are being dependent, that is been nothing but the laws of photoelectric emission. So we are having three laws. That is, first law is the number of electrons emitted per second is directly proportional to the intensity of the radiation. If the radiation has been very large or high, then more amount of, so for example, when you are having a solar power generation, so if the radiation of the sun has been higher, then I can generate more amount of energy such that as the intensity of the radiation is been more, then the more number of electrons are being emitted. That is the first law. Then the second law is the maximum kinetic energy of an electron emitted increases with the frequency of the radiation. If the radiation frequency is being varied, the intensity of the light variation or the frequency has been varied depends upon that frequency. For higher frequency, we are having more number of electrons can be generated, as well as for the lesser frequency, we are having a lesser amount of electrons are being generated. But there is a one limit. Below that frequency, no emission is going to occur. So there is a band. Above that, or there is a threshold frequency, that above that threshold frequency, only the electron emission can be started. That is the third law. There is a minimum frequency below which no emission occurs. So these are the three laws of photoelectric emission. That is, first one is as the intensity of the radiation increases, the number of electrons are being liberated more. And if the frequency of the radiation is being increased, then again still the number of electrons are being more. But when the intensity of the frequency radiation frequency has been, minimum frequency is required to start to emit the electron. So these are the three laws we are coming across in the photoelectric emission. So now we'll come to, in general, how it is going to work. You are going to see here different sources. This is one type of emission. I will explain. Then this is another one type of emission, and this is another one type of emission. Here we are having here in a circular fashion, here in a tube fashion. So here we are having a different shapes. Depends upon the application we are using. So these are vacuum tubes. So this is a glass tube which has been vacuumed, or it is also a vacuum. Inside there is no air, or here also there is no air. So here we are having two terminals. One is being called as a cathode, where it is being connected to a negative power supply, and this is being called as an anode. Anode is being connected to the positive power supply. Similarly, here also you can see this is anode is being, cathode is being connected, and the cathode is in the shape of semicircular, such that the electron which are being emitted are being directed towards the anode. Here also, when the light rays, ultraviolet rays are being falling on the surface, it starts to liberate the electron, and these electrons are being made to flow in a direction of towards the anode. Here also, when they are going to hit, they are being made, or it has been direction can be changed. So here, this illustrates how the emission of electrons are going to take place. The below figures illustrate the phenomenon of photoelectric emission. The emitter and anode are enclosed in an encapsulated glass envelope, and the battery maintains anode at positive with respect to the emitter, why we have been calling it as emitter, it emits the electrons. Therefore, here we are not using the term cathode, here we are using the term emitter, and this emitter is negative potential and the anode is positive potential. Here we have been creating the field of attraction. So when the light ray is not falling on this, no electrons are being coming, therefore this circuit is going to act as a open switch. So when the light of beam is going to fall on this surface, then it starts emitting the electrons, and these electrons which are being liberated, here we have been created a attractive force, that is positive force is being created here such that these electrons will be moving towards the anode, such that this circuit is going to act as a closed switch. Similar way here also, when the light ray falls on this, here the potential is been maintained. Potential is been maintained such that when the light ray falls on this, these electrons are being made to flow in this direction such that the circuit is been closed. Here also the circuit is going to closed. So what the explanation is tells, when a beam of light strikes the surface of metal, according to Planck's quantum theory, the energy of photons of light is transferred to the free electrons within the metal. The energy which is been emitted by this is a photon energy, and that energy, when it hits to the surface of the metal, the electrons which are here will get or absorb that quantum of energy. If the energy of the striking proton is greater than the work function of the metal, then free electrons will be ejected out from the surface of the metal. The amount of photoelectric emission depends upon the intensity of the light falling on the emitter and the frequency. So here, what the intensity the light has been falling, as well as what is the frequency of this quantum energy related to the emits of the electrons, that electrons are being made to flow to towards the anode. So this type is being called as a, or like this, the photoelectric emission works. Now we'll come to the first device, which has been called as a photodiode. So here, I think you have been already heard the name for diode. Diode is a PN junctions which has been made up of semiconductor, and one terminal has been taken from P type and another terminal has been taken from N type, and that we are going to call it as a PN junction diode. So, but what here you are having photodiode. So here photodiode, you can see in the market we are going to get the photodiode in this shape, and this is the symbol which we are going to use for the photodiode. So this is an ordinary diode, and here we are going to show the arrow mark which has been, it tells that when the light ray falls on this, it starts conduction. So this is the symbol what we are going to use for the photodiode. And when you come to the circuit, so this is P and N, here there is a junction, and here the lot of energy or the light energy has to fall at the PN junction, such that we have been connected one lens, and then lens this whatever the, so here it is a lens. So whatever the energy or whatever the light source are been falling on this, they are made concentrated and they are been sent to the falling on the junction which has been formed. So normally this photodiode is being connected in a reverse bias. So what is meant by reverse bias? When P is being connected negative with respect to N, as you have been seen in the diode characteristics, when P is being connected positive with respect to N, then it is being called as a forward bias. And when P is being connected negative with respect to N, then that is being called as a reverse bias. But the ordinary diode at the reverse bias does not conduct. Why I have to use this one always in a reverse bias? What is the main intensity? Because in the reverse bias, the resistance offered is very high. Therefore, this device can be having an input impedance very large. So wherever this input impedance should be larger, then there this application can be used, or this device can be used for such application where the input impedance has been more. Therefore, this photodiode is always working under reverse bias. What happens, how it is going to conduct? So you can see here in this. So when the quantum of or a photon of energy has been falling on this, which is going to liberate the electron hole, such that the electron will jump this side and the hole will jump this side, such that the conduction starts. Or it is going to have a small leakage current. When the diodes are in reverse bias, there is a leakage current which has been flowing due to the minority carrier. So this, when the light ray falls onto the junction, some electron hole pairs are being liberated, and these will increase the leakage current, that is the minority carriers, such that as the intensity of the light goes on falling on it, more and more number of electron hole pairs are being created. A stage is being reached such that the reverse bias junction is going to break, and hence the conduction of the PN junction takes place. So therefore here it is being connected. So which is going to, this energy is going to increase the minority carrier or a leakage current. And this leakage current is being goes on increases as the intensity of the photon or a light falls on this, such that at a stage this is going to act as a breakdown device. So that only we have been explained. Photodiode is a PN junction diode which conducts when sufficient light falls on it. The light energy can be considered in terms of photons or light packets. When light rays falls on PN junction, it creates additional electron hole pair within the device. This causes ability of more free electrons with the device. So the below figure shows the symbol of photodiode and working of photodiode. When no light is applied, the reverse bias junction creates potential barrier. Now the leakage current flows within the device due to the minority charge carriers. But when the light rays above 1.1 electrovolt strikes through the junction, when electron hole pair are generated within depletion region, these electron hole added with the leakage current increases the current flowing through the reverse bias junction. If sufficient light falls on junction through light window, then sufficient electron hole pairs are being generated within depletion region, and this increases the leakage current sufficiently and breaks down the photodiode in reverse bias PN junction. Hence, entire device is turned on. So like this, we can have the photodiode. So with this photodiode, when it is been reverse bias, but it doesn't conduct. So due to when the light intensity falls on the junction, which is going to create the leakage current, increase in the leakage current. When this leakage current is sufficient, such that the reverse bias barrier is going to break down, and now the PN diode is going to conduct in a reverse direction. And what are its applications where it can be used? So as I told, it is being used, for example, in a switching. So it can be used as a switching, that is means on and off. When the light rays is been not going to fall on that surface, it acts as a open switch. When the light ray falls on this, it acts as a closed switch. So wherever the switching application can be done, so there we can use this photodiode. Then useful in high speed switching and logic circuits. And in the third one is demodulation. So modulation means mixing of signals with the high carrier frequency, where in the demodulation, the separation has to be done. So there we are using this photodiode. Then detection both visible and invisible items, or invisible any devices I can use by using this. So if the light ray falls on this, it starts conduction such that whether it is a dark or light day, we can have the detection of the visible and invisible signals or a light rays. Then it can be also used in a logic circuits, and it can be also used in an encoder. Then it can also be used in a character recognition. So character recognition, it has been coming under what we will call data acquisition system. There, the character recognition is going to have these devices for their applications. Then we'll come to the second device, which has been called as a photovoltaic cell. So I can have this photovoltaic cell, the meaning has been different. So if I'm going to ask, have you seen the solar cell? Everyone is going to tell me yes. The solar cells are the common cells which are being used to generate the power, as you are going to see in so many buildings, such that the power generation they are using and the solar application, lot of solar applications are there. So there they are using. So these solar cells, actually they are being called a photovoltaic cell. So photovoltaic cell is a device which will convert directly light energy into the electrical energy. Directly light energy into the electrical energy. There are two terminal devices. These are the two terminal devices which produce voltage between the terminals when exposed to light. When they have been exposed to the light, they are going to start to generate the power. The voltage produced is directly proportional to the intensity of the light. If the light radiation or the intensity has been more power is being generated, or a more voltage is being generated. If it is a cloudy nature, then the power generation will be very less. If it is a very bright sunlight, then we are going to have the higher and higher generation. The basic photovoltaic cell consisting of P-type and N-type semiconductor materials. So here we are having a N-type and P-type, and here we are having N-type, and above which is a PN junction diode, and here a metallic ring is being connected such that here we are having a glass plate, and this glass plate where the light rays are going to fall to the PN junction directly. So when it is going to fall on a PN junction, so it is going to liberate the electron hole. So the electron will move towards down, and the holes are going to move towards the positive, such that a potential or a battery, it acts as a battery where the power generation takes place. So here all the holes are going to accumulate, all the electrons are going to accumulate here. When if it has been connected to any circuit, then the flow of current starts. So it is going to generate some small voltage. The basic photovoltaic cell consisting of a P-type and N-type semiconductor material forming PN junction, and the construction of the silicon solar cell comprising the PN junction with few metallic electrodes. So here what happens here also, it is also one type where completely we are having a glass through which the light rays are been coming, and this transparent conducting film is going to connect one, and here we have been connected. Then what happens, this is N-type, this is P-type. So here when the light ray falls on this, the liberation of electron hole takes place such that the electron will move upward and the holes are going to move such that it just acts as a battery where the accumulation of electrons on this side, accumulation of holes on this side, such that again if I'm going to connect this onto a circuit, again here also it starts conduction. And this is the symbol how I can use, that is, it is a positive and negative, and it has been with circle. Then when the light ray falls on this, it is the symbol of photovoltaic cell. So you can view here. So this is a solar cell. In this solar cell, we are having upper layer one this type and the lower layer one this type, and above which a glass, transparent glass has been fixed. So it is just like a similar to this. So here also you are seeing the lines, here also you are seeing the lines. So it is nothing but a photovoltaic cell. The cross section you can view like this. So here we are having two layers. That is, one is upper one is N-type layer and the second one is P-type layer. Then when the light ray falls on this, so most of the energy is being reflected back, but with some frequency, whatever the frequency we have designed, that frequency will enter inside and it is going to liberate the electron hole pair such that the electron will be move upper side and the holes are going to move downside. And now if this is been connected to any, then the circuit is been closed and now the power starts to flow. So this is a single cell. So like this, we can have a solar panel. Solar panel is nothing but individual cells we have been having here, and they are being connected in parallel and series such that I can have the higher voltage. So here one cell can only having a voltage of 0.5 volt. Each cell is going to produce me 0.5 volts. So if I want 18 volt from the solar, then we require how many number of solar cells we require? Each cell is going to produce me 0.5. If I want 18 volt panel, then I have to get 36. 36 cells are being connected in series such that I can have 18 volt panel. So like this, in the market we are having different panels, as well as 18 volt panel we are having, 230 volt panel we are having, then different panels were available, and these panels are being constructed by using only a solar cell, and each cell is going to produce me only 0.5 volts. How it works? When a light ray falls on this PN junction, when the light ray falls on this PN junction through a glass window, here there is a glass, a photon after penetrating through the P-type material hits an atom in the depletion. So here hits an atom in the depletion, causing an electron to break out of its covalent bond. Once the covalent bond is going to break, what we are going to liberate? We are going to liberate electron and hole. This causes the free electron hole pair. The electrons move into the N-type material, thereby adding a negative charge, whereas the hole drift towards the P-type material, thereby adding a positive charge. The photovoltaic cell can act as a battery. The solar cell operates with fair efficiency, has unlimited life, can be easily mass produced, and has high power capacity per weight. So here the life of this one has been very large, therefore this can be used to wherever there is a mass production of the power supply is going to take place, there we are going to use these cells. So here how it's going to work: when the light ray falls on this light ray penetrates towards the junction. In the junction, when this photon energy hits, here I am going to liberate the electron hole pair, and the electron will move to the upper area and the holes are going to drift to the lower, such that here the accumulation of electrons and here the accumulation of holes, which is just like a battery, and then that battery, when it has been connected to a load, it starts giving the supply. Like this, the solar cell is going to work. The solar cell is going to convert the solar energy, that is light energy, directly to the electrical energy. So where it can be used, as you have been seeing, so wherever you go, you are going to see now our Karnataka is going to be one of the leading manufacturer or the power production by using a solar. So where we have been having a mass production or a huge production. So therefore, in almost all applications, if you go for your Dharmasthala, there the cooking of the rice is being done by using, or if you go for Tirupati. So in some temples, they are going to have the solar application. So such that here the application in a street light. So when you are seeing the street light, so in the daytime they are not going to on, and in the evening time only that lights are going to off. So therefore here the street light, how it is going to make it on at the right time and in the daytime it is off. So here we are to have a battery backup. To charge that battery, we are having a solar panel, and through that solar panel, the energy is being charged in the daytime, and in the night time, this DC is being converted to AC, and your street lights are going to be on. So in the street light application, we can use the solar cell. And in some cooking applications, so here directly we are not using a solar cell, we are using a solar principle, that is solar heaters. So the light rays are being made to fall on a particular area, and that heat which is being generated is being made concentrated to convert it into the heat, and there the cooking application can be done. Or in a battery operated vehicles or a solar operated vehicles, where the vehicles can be used, there the charging of that battery is being done. On the top of the car, we are having a solar cell, and due to this solar cell, the charging of battery and the battery charger is being used to move the vehicle. So nowadays it is very familiar that we are having a car which has been coming by this solar cell. And the energy in the satellite. So in the satellite, the power has to be provided such that to work the satellite. So there we are having a solar cells. That solar cells are being directly exposed to the sunlight, and that sunlight causes the power. That power can be utilized in the operation of the satellite. In solar energy production, so it can be used to produce the heat, or it can be used to produce the electricity. In almost all these fields, we are going for solar cell. So solar cell are the devices which are going to generate electricity directly from the solar light. And the third device, which has been called as a light emitting diode. Or for example, you have been seen wherever you just go, you can see this different coloring LEDs. We are very familiar with the LEDs. So what is that LED? LED is nothing but a light emitting diode. It is a special PN junction diode that emits visible light when it is forward biased. So when it has been forward biased, it starts emitting the light. So that the symbol can be given like this. It is a reverse of the photodiode. So photodiode, the arrow mark are been falling on the junction, so where the light ray causes to conduct, but here when it is been forward biased, it starts emitting the light. How this light are being emitted, how this energy is being produced. So as you know that we are in a semiconductor material, the outer orbit energy levels. So outer orbit electrons or valence electrons are having a higher energy level, and in the inner we are having a lower energy level. If this outer energy level, if I am going to remove the energy of that electron, it will jump from the last orbit to the next inner orbit. So when this energy which has been taken out, it has been coming in the form of light. So that technology we have been used here. So when current is made to flow in the forward direction through, so these are the materials which are being used to construct the LEDs, that is gallium arsenide phosphide, GaAsP, PN junction. Visible light is emitted from the region of the depletion region. This is due to the recombination of minority carriers, so that when an electron falls from the conduction into valency band, energy is released in the visible form. Such a light emitting diode is referred to as a LED for short. So what happens in the semiconductor material, when the heat treatment is been given, the valency electrons will jump from valency band to the conduction band. So here that is a reverse process. When from the electron which has been jumping from conduction band to the valency band, it emits the energy, or it leaves the energy. That energy has been coming in the form of visible form. However, in case of LED, this power, so for example, in a normal diode, what happens? The power is dissipated in the form of heat energy. So when the diode is being made forward bias, it starts conduction. but when the current starts to flow in a diode, so this diode, the energy which has been flowing is been coming in the form of heat, or the power is been dissipated in the form of heat, but in the LED, the power is been dissipated in the form of visible form. Dissipated in the form of visible light, as it has been shown. These are the symbols, and these are the practical, or in a market you are going to see the LEDs like this. Although most LEDs have a peak spectral response at 6,600, red, yellow is 6,100, and green is 5,600. These are the different wavelengths, spectral wavelengths, so such that at this, when the LEDs are working, they emit the different colors, that is red, yellow, and green, and so on. So this is the construction. So here is a simple P and N junction, so such that when the supply has been given, what happens here, the recombination of minority carriers takes place when they are going to jump, or from the electron which are been here are been jumping to this, to the hole, so they starts emitting the energy, and that energy has been coming in the form of light energy. So what are the applications? They are commonly used for indicator lamps and readout display in many instruments, for indicating power on and off condition, power level indicators in stereo amplifiers, for solid state video display, which are rapidly replacing cathode ray tube. So nowadays, previous you are having nowadays the TV. What type of TV you are now you are having? You are having a LED TV. Before that LED TV, we are having a LCD TV. Before that LCD TV, we are having a CRT tube TV. So this CRT display is being now replaced with the solid state devices, that is LCD. Then again that LCD has been replaced with now LED. So now the latest technology which has been coming in the TV is LED. For image sensing circuits in picture phone, in bulgar alarm systems, where the controlling, or where the what we will call bulgar alarm is a special alarm which has been used as a safety device. In a safety, we can have a red LED. If that red LED comes, means there is a danger. So like this, we can use in a bulgar alarm system, and LED radiates infrared lights are preferred. So that is in bulgar alarm system, the brightness of the LED must be very bright, so that it has to radiate the infrared lights are preferred. So like this, it is having a different applications where we can have a display, or where we can have an advertisement. So in lot of applications, we are using these LEDs. So now I will stop here only, then I will continue in the next class. If any doubts, you can ask.